Hi everyone, so we started our lesson today on solving exponential equations, and we put up a few questions for you to have a go at and to try and solve. And I'm going to work through in this video the solution to those problems now to help you work more independently when you have a crack at the exercise yourself. So let's actually run through these one by one. I'm going to start with the problem that said solve 4 to the power of x equals 64. So this is my most simplest problem. I can use my basic literacy and understanding skills here to read this expression and just solve it using common sense. So I'm saying 4 to the power of something equals 64. Then the something must equal 3. Because 4 times 4 times 4 equals 64. The end. Know your powers, or at least be able to sort of work through them. Same deal again for my second problem. A little less obvious, but we're saying 5 to the power of something equals 625. As mentioned in the previous question, we can use common sense again to try and solve this, but because it's a little bit harder, if you need to, you might just want to write down your powers of 5. So 5 to the power of 1 is 5, 5 to the power of 2 is 25, 5 to the power of 3 is 125, 5 to the power of 4 will be 625. So quickly jotting them down can help you work out that x must be 4. All right, moving along now, we have 125x equals 5. Now this one can be a little bit tricky because we start to think, what's going on here? The numbers got smaller. Normally when we have powers, don't they get bigger? But without too much, again, sort of logic and thinking, what number would I have to have here to make it work? We can logically come up with that it's got to be the cube root of 125 equals 5, because 5 to the power of 3 equals 125. So therefore, x would equal 1/3. But if you're having trouble with that, what we can do is we can write both parts to have the same base. So let's write this 125 with a base of 5, and that would be 5 to the power of 3. And then on my right hand side, my base is 5, my power is actually 1, and I'm going to write the 1 to help me with the working out. On the left hand side, we've got a power to a power, so in these cases we multiply them, 3x, and then now we know my powers must be equal, so 3x must equal 1, and x equals 1/3. So this question would only ever be worth 1 mark, so you can use a common sense approach. But if you're having trouble with the common sense approach, this is how I would show my solution algebraically. So they're probably the first 3 types of questions that we saw in the Engage activity. My next ones is when we start to incorporate some algebraic expressions within the powers. So when we have problems like this question here, 3 to the power of 2n minus 1 equals 1/81, my approach for these problems is always to get myself a common base value. So here, I know that 81 is the same as 3 to the power of 4. Okay, so we've got 3, 9, 27, 81. They're my powers of 3. Helps to sort of try and remember these. If you need to have them written down somewhere in a page in your book, you might like to write down the first, say, 5 or 6 powers for the some base numbers like 2, 3, 4, 5, 6, etc. Okay, now my next step in this problem is I'm going to get my power, my 1/3 to the power of 4 as a negative power. So now I can really clearly see I've got a base of 3 on my left hand side, a base of 3 on my right hand side. So now I can ignore the bases. The only way these two expressions are going to be equal is if 2n minus 1 is equal to minus 4. So let's write out just that part of the expression. 2n minus 1 has to equal negative 4. And from here it's solving a linear equation. And you should be getting quite good at this by now. And hopefully I've done that quickly. So we add 1, divide by 2. And there's my solution for n. Alright, the next question I wanted to choose to do is very similar to the one we've just done, except we have an inequality now. The process is exactly the same, except instead of having an equal sign, we have the inequality. So get the same base. And then the only way this will work is if I have 2x plus 1 must be greater than 3. And then I can solve from there. 2x must be greater than 2. X must be greater than 1. Okay, so x must be greater 1 if 4 is going to be greater than, 4 to the power of 2x plus 1 is going to be greater than 64. Let's move right along to my next expression. So we now have 2 to the power of minus 3n times 4 to the power of 2n minus 2 equals 16. So what I'm hoping that you're going to start to get into the habit of is straight away saying, my base numbers are not the same. My first step is let's make my base numbers equivalent. Let's get the same base for all of my problems. So 4 is the same as 2 to the power of 2, and 16 is the same as 2 to the power of 4. Okay, tidy up this part with my index laws. So I've got a power to a power, I times them, and then when I multiply, I add the powers. So if I put them together, I'll do that in 2 steps to show my workings more clearly. This becomes 2 to the power of 4n minus 4. Now I'm going to add my powers. I get 2 to the power of n minus 4. Because negative 3n plus 4n minus 4 is 1n, take 4. And now that I've got down to just a singular base number on the left-hand side and the right-hand side, I can solve this by making my indices equivalent. And I'm done. Okay, my next problem, I'm going to start off the same way, but this problem takes a little bit of a turn. So, same idea as before, let's get them to have the same base. So this is 3 squared to the power of x minus 4 times 3 to the power of x plus 3. And then use my index laws to simplify this power to a power. We get 3 to the power of 2x minus 4 times 3 to the power of x plus 3 equals 0. And my problem here is I can start to sort of think, what is going on? My powers don't match. I've got pluses and minuses in between. So the minus and the plus in between. There's no index laws for when I have a plus and a minus in between. So we've got to come up with another solution or another method for solving this problem. And what I'm going to propose to you is this expression here has a 3 to the power of 2x and a 3 to the power of x. If I want to be really creative, I could say that this is 3 to the power of x to the power of 2. Because when I have a power to a power, I times them. That would be an equivalent expression. And this second one is still 3 to the power of x plus 3 equals 0. And I hope by making that change, what you might spot is that this is a quadratic equation. And if I let 3x equal a instead, it's really easy to see that quadratic equation. So it becomes, replace the 3x with an a, it would be a squared. Replace the 3x with an a, becomes 4 times a. No 3x in the constant term at the end, so I just leave it as 3. So if we replace the 3x with an a, it's really easy to see the quadratic equation. We can now factorize this and use the null factor law to solve it. So I would get a minus 3, a minus 1, so that a must equal 1 or 3. Cool, so we've found out what a is, but the question never asked me to find out what a was. The question asked me to find out what x was. So I'm going to now replace the a with 3x and solve both of these parts separately. So now, when a equaled 1, it means that 3x equals 1, and 3x will equal 1 when x equals 0. When a equals 3, that means 3x equals 3, and 3 to the power of x equals 3 when x equals 1. And now I have my final solutions, and there's more than one of them. This expression up the top will be equal to 0 when x equals 0 or when x equals 1. And that's the question is complete. All right, last one. So what do we do now when we have 4 to the power of x equals 6? So we might sit there and we say, okay, we're going to play around with something like, what if it was 2 squared to the power of x? Can I get 6 with a base 2? No, I can't. So I haven't got a singular base here. Right, and that didn't work. Can I write 6 as having a 4 to the power of something? Can I do that? No, there's no way I can get an answer of 6 by raising 4 to the power of something. Or I probably can, but it's not going to be an easy number that we can work out, obviously, just by guess and check. So we're kind of stuck here. And this is where we need some kind of method of getting rid of my base number. I need some method for undoing the power. We need a method for undoing the power. We need an inverse operation for exponentials, or for exponents, or for indices. Okay, and my inverse operation, so when I say inverse operations, the inverse of plus is minus. The inverse of times is divide. The inverse of squared is the square root. The inverse of a power is a logarithm. So the inverse of exponents are logarithms. So if I wanted to do this problem, I would take the log to the base 4 of 4 to the power of x, and then I would take log to the base 4 of 6. So I've done the same thing to both sides. I've taken a log of both sides. And then we're going to learn more about logs later on. What I'm going to tell you here is this log to the base 4 of 4, they cancel each other out, and I'm just left with x. And this log to the base 4 of 6 is actually the answer. When you type that into a calculator, let me just see if I can find my calculator here and do this problem for you. My calculator's not here, sorry. When you type that into the calculator, you're going to get a decimal answer. Give me a moment, I'll finish this video by looking up, finding my calculator and doing it for you very quickly. Just have to wait for a moment for it to work. So you can type this into your CAS calculator. You'll notice on the left hand side of the keypad there is a little blue log. So you press Control log on your calculator. Control log. You tell it what base number you want, which is 4, and then type in the 6. Press equals, and you get an approximate answer of 1.29248. And we're going to learn more about logarithms in a future lesson. Thanks.